What if we could weave materials at the molecular level, just like fabric? Well, molecular weaving is finally here.
You know how materials are usually strong or flexible? It's always a trade-off, but what if it wasn't?
That's where mechanically interlocked materials, or MIMS, come in. It's literally like knitting with molecules.
And the possibilities? Whoa! We're talking breathable armor, next-gen sportswear, even flexible electronics.
Okay, but there's a catch. Actually, designing these things is super slow and computationally expensive, a real bottleneck.
So the solution is something called the WCT model. It's basically a digital twin for these weaves.
Let's peek under the hood. This first part of its equation is like a weather map for stress distribution.
Next up, this part adds in the local stiffness. You know how rigid each specific point is?
And here's the real magic. This nonlinear term models how the material gets tougher under pressure.
Put it all together, and this last piece is just the force you're applying, like a push or a pull.
So what's the payoff? The model answers 3 key questions. How stiff? Will it break? Where is it weakest?
Okay, this all sounds pretty amazing. But how do we actually know this thing works? Is it for real? Well, they put it to the test. A serious 3-part validation to make sure it's absolutely solid.
First, they checked if it gets more accurate with more detail. And, yep, it did. The error shrinks right on cue. Then, they put its predictions up against other simulations and real lab results. The numbers? A near-perfect match.
So, the verdict? It's consistent, it's accurate, and it's credible. This thing is the real deal. And they're not stopping there. There's an 18-month plan to turn this into a full-on design toolkit for scientists.
The dream is a tool where you can just draw a weave pattern and see its properties right away.
This is what finally closes that gap between a cool idea on a screen and an actual real-world supermaterial.
The impact here is just huge. We're talking about discovering new materials more than 10 times faster.
So, it really makes you wonder, right? If you could design any material this way, what would you create?